I have an example problem here. A 20 centimeter diameter plastic disc is charged uniformly with an extra 10 to the 14th electrons. What is the electric field 3 millimeters above the center of the surface? All right, so here's our disc, kind of trying to draw a side view. We have a bunch of electrons everywhere, and we want to find the field, a distance of 3, not 30, millimeters above that surface. Okay, well, this is a disk. So I'm going to go and find E of a disk off the test notes. It looks like this. So eta is the surface charge density, meaning the total amount of charge divided by the area that the charge is covering. Epsilon naught is a constant in the denominator. Z is that distance, the 3 millimeters. That's the distance along the axis. The axis that goes through the center. Capital R is the radius of the actual disk. We're given a diameter of 20, so the radius is 10 centimeters. Now this disk has an extra 10 to the 14th electrons. So the charge on the disk is going to be this number of electrons times the fundamental unit of charge, the charge on one electron. So that's going to come into play here in finding this surface charge density. Q is going to be this 10 to the 14th electrons times the charge on one electron. So that's the net charge on this disk. The area of the disk, well, it's a disk, so it's a circle, so we just want pi r squared. And we do want this to be in meters so that our units work out correctly. So our surface charge density, if I go ahead and plug these numbers in, our surface charge density is 5.093 times 10 to the negative 4 coulombs per meter squared. And that's what needs to go in for eta right here. So now we have everything to plug in. We just need to solve for this electric field. Now, as we plug these numbers in, this is going to give us just the magnitude. We will talk about the direction as well. So there's eta, epsilon naught, 8.85 times 10 to the negative 12. All right, so Z is 3 millimeters, which I want to be in meters. 0.003 squared plus R is 0.1 squared. I'm going to plug this all in. If I've plugged it in correctly, and and I'm getting 2.8 times 10 to the 7th. The units will be newtons per coulomb. The coulomb and meter squared in the numerator cancel with one of the coulombs, and then the meter squared in the denominator. The units inside the parentheses, well, there are no units inside the parentheses because the meters up here cancel with the meters that this denominator would have in the parentheses. So this is the magnitude of the electric field. The direction, electric field is a vector, so we need to describe it completely. The direction of the electric field is towards the disk. With the wording of the problem, it says to find the electric field at this point above the center of the surface. That's why I drew my disk horizontal. So this point up here, above it, towards the disk would be down. So down or towards the disk is the direction for this electric field.